The icons class functions similarly to the colors class. It offers hundreds of built-in icons that can be easily used in Flutter applications. To reference a specific icon, just call it by name, for example, icons.home. These icons can be inserted into widgets like buttons or used as decorative elements within the user interface. Their appearance, such as size, color, and alignment, can be customized using the properties of the widget they are placed in. For instance, in this basic example, we have a column containing three icons: man, home, and woman. They are displayed using the icon widget, with specific colors and sizes applied. It's important to note that while the two icon colors are set using the colors class, the third uses a special constructor from the color class. This constructor takes four parameters: alpha, which sets transparency from 0, fully transparent, to 255, fully opaque, and red, green, and blue, each ranging from 0 to 255 to define the color. While we won't go into the details of Dart constructors here, this example shows how to use the color class directly when more precise control is needed. Let's now start exploring stateful widgets. Before diving into their structure, it's essential to understand when and why they are needed. This simple example builds on the familiar app layout, but this time the child of the center widget is a text button. A text button is a stateless widget that displays a text label, which can be styled, for example, with a custom font size. One key property is onPressed, which specifies the function to run when the button is tapped. This illustrates event-driven programming, where code executes in response to user actions, events. The onPressed parameter can take either a method reference, not a method call, from the same class, or an anonymous function, an inline function with empty parentheses if no parameters are needed, and the function body inside curly braces. In the example, the function body only contains a comment, so clicking the button has no effect, no matter how often it's pressed. Before moving on, it's worth noting how buttons look and feel. Following material design, a text button appears as simple tappable text by default, with no border or background. This can be easily customized through its style settings. Now, let's look at a simple use case for a button. Each time it's pressed, its label switches between true and false. To make this work, we need a piece of state that updates based on user interaction. This is exactly where a stateful widget is required. While the button remains stateless, the widget managing it must be stateful so it can update the label dynamically whenever the button is clicked. As usual, we will stick with the familiar app structure. The first key change is that the child of the center widget is now a button control. Since we are only managing a single button, there's no need to make the entire My App widget stateful. In other words, we don't need the whole screen to be state-aware. State should always be kept as localized as possible. At this stage, there's nothing fundamentally new, but this marks the introduction of our first stateful widget. So let's go ahead and define it. Button control is the stateful widget that controls a stateless widget, our button. As mentioned earlier, defining a stateful widget requires two classes. The widget class extends stateful widget, and its constructor only includes the inherited key parameter. It also overrides the createState method, which returns an instance of the associated state class, in this case button control state. While this can be written using the standard function syntax, Dart, like any modern languages, supports arrow notation for simple methods. So, createState just creates and returns the object that manages the widget state. The state class, commonly named button control state by convention, extends state button control, although the name itself can be anything. This class holds the widget state, which in our case is a single Boolean variable, active, initially set to false. It also defines the build method, which returns the widget tree. In this example, the build method returns a center widget with an elevated button as its child. The button uses two key parameters, onPressed, which is set to the handleClick method to respond to taps, and child, which defines the button's label. The label is chosen using Dart's conditional expression column, showing true if active is true or false otherwise. The handleClick method takes no arguments and returns void. Its role is to update the value of active. Any state change must be wrapped in a call to set state so that Flutter knows to rebuild the UI. When the button is first displayed, active is false, so the label shows false. Once clicked, handleClick toggles active to true, triggers set state, and causes build to rerun, updating the label to true. While handleClick is written as a separate method here, it could just as easily be written as an inline function. Now that we have all the ingredients, we can focus on some examples to better understand what we can do.